On the main streets of America, busy retail stores serve the people of their communities. These shoppers spend billions of hard-earned dollars, and they want the best values those dollars can buy. These customers are, at other times and on other days, people with many different jobs, different needs. The retailers of America serve these people well, providing a wide variety of merchandise of good quality at reasonable prices. This service is made possible largely by the quality control methods used in modern merchandising. Making a purchase is a comparatively simple action. However, it takes a great many creative, mechanical, and scientific processes to make a piece of merchandise fit a precise human need. Behind a package like this one lies the dramatic story of how retailers study and meet the needs of their customers. Shirts, for example. Men want shirts that fit well, smooth-fitting collars that hold their shape. Their wives like shirts that launder easily, shirts with long-wearing collars and cuffs. And what customers want, the retailers provide. Months before the shirts reached the store, experienced shirt buyers carefully selected the fabrics which make the kind of shirts the customer wants. Samples are laboratory tested, and only those that meet the required standards are accepted by the buyer. Now that the approved fabrics have been selected, let's visit the cotton mill with one of the buyers to see how the high quality specified is maintained during production. At the mill, the raw cotton goes through many processes. This is the combing operation, which combs the long fibers parallel and removes the short fibers and waste. In the drawing operation, the combed fibers are drawn out to greater length. These processes help improve the appearance of the finished fabric. Spinning draws and twists the fibers into yarns of the desired size and strength. The yarns are woven into fabrics on power looms. At speeds too fast for the human eye, the shuttle races back and forth, carrying with it the filling yarns, which are woven with the warp yarns to form the fine broadcloth from which the shirts will be made. But before the fabric is ready to be tailored, it goes through many finishing operations. In mercerizing, which produces a smooth, silky finish, the cloth is treated with caustic soda while it is held under tension. Finally, the fabric is sanforized, processed so it will not shrink more than 1% in laundering. Having assured himself that the broadcloth meets required standards, the buyer orders it delivered to a manufacturer. He reviews the features he wants. For instance, the cuffs and collars must be made of long-wearing material, and shoulders cut with plenty of fullness. Now the buyer follows through by visiting the shirt factory. Specifications and patterns are given to shirt factories all over the country to maintain uniformity of product. With painstaking accuracy, skilled craftsmen cut the parts for many shirts at a time, from fabrics piled 100 or more layers deep. Permanent collar fit is built in on these machines, which remove every last bit of shrinkage. These collars, as well as the cuffs, are constructed from extra sturdy material to ensure long life. And now to the laboratory, where merchandise is tested, a major step in quality control. This is a test to determine how much the fabric will shrink. Samples are carefully measured and marked, then given a thorough washing in the type of machines used by commercial laundries. Samples are pressed dry and flat so they can be accurately measured again and the exact degree of shrinkage determined. If the fabric is sanforized, it must not shrink more than 1%. The collar and cuff materials are tested for toughness and durability. A thread count of both warp and fill is made to be sure the broadcloth contains the required 220 threads to the inch square. Even the buttons are tested to make certain they will not break in the power presses used by commercial laundries. Those samples that fail the test are rejected long before the merchandise reaches the retail store. All of this testing has but one purpose: to provide the customer with sound merchandise of good value. How long a shirt will wear is a topic of frequent discussion among the nation's housewives, and that goes for sheets, too. Housewives want sheets that are smooth and closely woven, good-looking sheets, but they must be sturdy enough to stand up under frequent washings at home or in commercial laundries. A label like this on a muslin sheet is insurance of long and satisfactory service, service proved by laboratory tests and controls. For instance, the weight of sheets must be kept uniform continuously. A good sheet should last for several years of normal use. In this laboratory test, which duplicates home laundering conditions, the sheets are washed again and again. This chemical test shows how much of the weight of the sheet is sizing, a starchy material usually required for proper finishing during manufacture. It must be kept to a minimum so that customers receive full value in sturdy cotton, not starch. The sizing is removed in a chemical bath. Then the samples are rinsed, dried, and weighed again to see how much of the original weight consisted of sizing. Among other tests is this one for tensile strength, an accurate measure of the amount of force it takes to pull the sheeting fabric apart. These tests and others like them, conducted year after year, make it possible for the retailer to provide customers with merchandise of uniform quality. Blankets, for instance. There's a big story in the quality controls required to provide real value in an all-wool blanket. Control starts with the raw material, wool. Various types are selected and blended: soft and springy for a nap that will stand up, sturdy fibers for long wear. Several variations of a blanket may be presented for the buyer's consideration. Laboratory tests of samples guide the buyer in determining the final specifications he gives to the mills. But quality control doesn't end there. It continues all the way through actual production. The buyer makes periodic visits to the mills. Control starts with the first manufacturing step, the scouring process. Raw wool is thoroughly cleaned and prepared for later processing. The cleaned wool is then carded, a process which removes the shorter fibers and material unsuitable for high-quality woolens and arranges the long fibers so they can be spun into yarn. Spinning draws the wool fibers out and twists them into the sturdy yarns required for blanket weaving. The spun wool is woven into blanketing material on wide looms, hundreds of them, all working at once in a large factory like this. The blanket fabric is washed thoroughly to remove the dirt and processing oil, so it will take the dye evenly. Dyeing is an essential step in making high-quality blankets, for the color must remain true through many years of service. An on-the-spot check by the laboratory head indicates the importance of this chemical treatment, an effective protection against moth damage. The dyed fabric goes through the napping machine, where the familiar soft, fuzzy finish is produced. The warmth of a blanket depends in large part on the insulation provided by millions of tiny air pockets in the nap. Finally, the fabric is cut into the proper size, then the blankets are bound and folded, ready to start on their journey to the retail stores. Production samples must pass many tests, including strength, weight, shrinkage, color fastness, before the finished merchandise merits this laboratory-tested and approved seal. Here's how the laboratory tests that most important quality of a blanket, its ability to retain warmth. to keep the customer warm. The technician establishes the amount of electricity needed to keep this cylinder at body temperature for 1 hour in a refrigerator set at 30 degrees. The cylinder is then wrapped in a sample piece cut from the blanket being tested and replaced in the refrigerator. The amount of electricity it now takes to keep the cylinder at body temperature for 1 hour is measured, and the difference between the two readings is an accurate measure of the warmth retaining quality of the blanket. Moth damage is an ever-present menace to wool. The hungry larvae of these flying moths can ruin a blanket. But moth damage can be prevented by treatment with Immuno, one of several tested processes known to be effective. These two sample strips of blanket have been exposed to the action of moth larvae for the same length of time. The nap of the untreated sample has been practically eaten away, while the treated sample remained untouched despite the presence of larvae like those you see here. To make sure that sufficient moth-resistant chemical has been used, samples from every production lot are tested. The samples are dissolved in acid, distilled, and the resulting distillate analyzed to provide a positive check. These tests provide a steady stream of facts and figures which finally take their place on labels like this for the customer's information and protection. Now, let's see what has to be taken into account in producing shoes to meet the customer's needs. Just imagine what it takes to make a shoe which can take the treatment it gets from an active growing boy. And at the same time, children's shoes must be designed and made to allow the foot to develop, but not at the sacrifice of appearance. And speaking of appearance, that's the #1 requirement in women's shoes. Yes, shoes are big business. American retailers sell nearly 500 million pairs every year. There are hundreds of styles, sizes, and varieties for men, women, and children, for people of varied tastes, different incomes, and many occupations. Providing what the customer wants is the prime concern of the shoe buyer. He considers carefully many styles and designs and discusses all the details with the shoe manufacturer. Sole materials are selected with particular care. To ensure good service, leather soles must be cut from that part of the hide known as the bend. Bend leather is better because the leather fibers are closely knit. Sole leathers and other components are tested both before and after production. This abrasion test is a check on the sturdiness of sole leathers. Shoes are taken from production and brought to the laboratory where sections are punched out for testing to see if the shoes have been properly sanitized, a process which reduces damage from perspiration and limits the development of odor by retarding the growth of bacteria and molds. Sanitized helps keep shoes hygienically clean and tends to make them wear better too. Samples are placed on a culture medium which has been inoculated with a known active bacteria. The bacteria are allowed to grow and develop. Meanwhile, let's see how the treated leather resists molds. 2 sample strips were kept in contact with mold spores. The sanitized sample has completely resisted mold growth, while the untreated sample shows what would have happened to an untreated shoe subject to the same conditions. Now, here are the results of the test made with bacteria. Note that they've grown right up to and under the untreated samples on the left, while the treated samples have remained unaffected. Sanitized has actually created a sort of safety zone, a clear circle around each sample where bacteria could not and did not grow. This process is especially important in work shoes. Quality control applies not only to work shoes, but to work clothes as well. Just think of the service they must provide. Work clothes must be planned for unusually hard wear, strong fabrics, tested fasteners, reinforced seams. They must be designed for comfort and utility as well. Each trade requires its own special kind of work clothing. Each workman wants his clothes made so he will have easy access to the tools of his trade. The matched set of work clothes is popular and practical for many kinds of jobs. Colors of pants and shirts must match. Neat appearance depends on proper fit. To ensure proper fit in clothing for men of many builds, more than 50 different patterns are carefully made in graduated sizes. The buyer has master patterns made to his specifications. These are sent to various manufacturers, enabling them to produce work clothes of uniform size and quality. Buyers specify quality of the fabrics and the many other items that go into garments: pocketing materials, zippers, buttons, tags, labels, rivets, and buckles. Before these materials are approved, they are thoroughly tested and checked in the laboratory for wear, washability, strength of seams, and other factors. Another kind of test of great importance for certain fabrics is the flammability test. Practically all clothing fabrics will burn, but how fast they burn is the measure of their relative safety. Samples are dried in an oven, cooled in dry air, then mounted in the tester. The small flame is applied to the fabric sample for 1 second, and the rate of burning is recorded. This highly flammable material is obviously not safe. A slow rate of burning is satisfactory. This particular sample did not even ignite. Another type of testing controls the quality of rainwear. Fabrics tested by this hydrostatic pressure device must remain waterproof for at least an hour under the pressure of a measured column of water. This spray test makes sure sufficient water-repellent compound has been used to give the fabric adequate protection. This test duplicates various rainy weather conditions to see whether the fabric construction and its water-repellent finish are suitable for use in rainwear. Materials can be subjected to a spray equivalent to a light shower, a moderate rain, or a heavy rainstorm. Laboratory quality control is applied to many other fabrics too. Yard goods, for instance. In the yard goods sample room, buyers, manufacturers, and artists meet to plan production. Color, design, and style trends are the subjects of constant study and discussion. Hundreds of new prints are brought out each year. Designed and produced especially for the thousands of women who sew at home, these fabrics are not only excellent dress materials, but can be used for curtains and the many other things a clever woman can make at home. And now let's see what is done in the laboratory to ensure customer satisfaction. For one thing, these fabrics are tested in a laundrometer, a scientifically designed washing machine for laboratory use. The individual samples to be tested are attached to white test cloths and put in separate jars containing steel balls and a solution of soap and washing soda. These tests can be varied to duplicate different laundering conditions. They can be agitated, like this, for 45 minutes at 160 degrees to see whether the fabrics may safely be sent to an ordinary commercial laundry. To see the results, samples are removed from the jars and examined. This sample has failed the test, coloring the wash water, fading, and staining the white test cloth. This higher quality print has come through the test with flying colors, not a trace of fading or staining. In these machines, called fadeometers, the exact degree of light fading can be tested for cottons, drapery, and upholstery materials, and fabrics used for making outdoor wear. Samples are exposed to rays of light relatively brighter than the sun, more than long enough to determine resistance to fading. At the end of the test, the part of the sample exposed to the light is compared with the part which was protected from the light. This sample shows considerable fading and will be rejected until a correction in the dye has been made. But the other sample has not faded at all and will be approved. Printed or dyed fabrics are tested for crocking to see whether the dye will rub off and stain other materials. This fine quality print did not stain the test cloth, but the other test cloth shows the result of a test on a fabric which was not approved. Colors may also fade and run due to the action of perspiration. This test will determine whether any of the textile fibers will be affected. Each sample is placed against a test cloth woven in strips of wool, rayon, silk, cotton, acetate, and nylon, wetted in synthetic perspiration, and then held under pressure and placed in an incubator kept at body temperature. Later, the samples are removed from the incubator and examined for color fading and staining of the test cloths. This sample has stained all of the strips of fabric, while the satisfactory sample has stained none of them. There's a very special test for acetate fabrics of certain colors for gas fading, which means color change due to atmospheric gases produced when air comes in contact with hot metal. And so the work of laboratory testing as a means of quality control continues. The fascinating application of scientific research and analysis to the problems of producing satisfactory merchandise for the customers in America's retail stores. The merchandise which, once it has been tested and approved, is stocked and sold by the retailers as a genuine service to the people in their communities. The continuing job of creating merchandise to meet precise human needs, is made possible only by modern methods of quality control. Whether it's hosiery, a pair of shoes, a shirt, or whatever the customer buys, it must represent the best value possible at the price. And responsible retailers can offer just such values, largely because of the part played by quality control in modern merchandising.